She's all like at this point for pretty weeks right now. So like I haven't environment, but even like what you mean by just from your mother, she can start feeling the case. Nice. No clue. Worst person to ask for getting process stuff. I think I don't know. Did I miss something? Like I get worried. But it's like I missed it whenever you're talking. No, I'm sorry. I'm sorry. I have no idea. Yeah, literally. Yeah. Hypothetically.
Sure.
So would you such
That's how it is of this guy. So what you need to do is going to remove the body.
so remove the H,
H, so it's T minus 2. This section not a curve. So the layer change space by way to the two, it is like a somewhere in the back. On the minus much. And it doesn't work. Let me come to the center. Because sometimes the gradient is strange. Yeah, it's also the concept is actually right. Okay, but the input is I don't know show things, but I will come up with this screen of the source so I can oh yes,
But that's the I double checked everything just got me answered.
Next question. Is it supposed to be, do you have to take to see the individual data points and then plug it into the integrator group, or is it not? Because if you do that, would you integrate the Y intercept should be the initial. So I just kind of assumed that was doing it.
There's one right? Right.
Yes.
So let's consider what is this question?
I think we're going to concentration.
So it will be, I guess this is just value of 15, 1 over 15.
Yeah, I put some notes there, but you got it wrong as well.
Yeah, so the value 1 over this number. This is actually the same. If you say wrong, then it's actually consider the significant. If it's a case, you have to be out of context.
Okay, gotcha. So it's simply one.
I was never to say that.
I can, right?
That's so strange. I said something. So. That. But I'm lost. But fortunately, you can find me.
Okay, so let's get started. Okay, so I think the first thing I want to mention is that you guys can start to review your midterm now. Okay, so the midterm one, the test period has ended. Okay, and then starting from today to next Wednesday, you will be able to actually revisit your exams, right? If you found that some questions that you know how to do it, okay, but somehow you did not get the point. Okay, and what you will need to do is that write down the process. Let's describe how you get your number. Okay, not the correct answer, but how you get your number. Okay, and then explain to me why you think you are doing it in the correct way. Okay, I will look at your work and give partial credit. Okay, the exam. Okay, so, and that's actually the other thing is that because you did all the things on Cengage, Cengage sometimes is very picky about the way you input your answer. Okay, so it may be actually super picky about the significant figures that you input. Okay, but if it doesn't specify explicitly about what is the format you need to input, okay, and you did not get a point, screenshot that to me, explain, and then I will give you partial credit back. Okay, all the things need to be done before next Thursday. Okay, all this correction need to be finished before next Thursday. Okay, so I will strongly encourage you to revisit your midterm. Okay, and this is also a very important step for you to prepare your final. Okay, because the most efficient way to prepare your final is really know all the things that you got tested in your midterms. Okay, so do print the things out. Okay, and then if you did it wrong, try to figure out what is the correct way to do it. Okay, so yes.
Looking at the midterm process.
Engage, yes. Yeah, and also I want to emphasize that by now you should have some idea, or you should have good idea about how you can actually score well for this courses, right? But basically, I hope you see what I say in the beginning of the semester is real. Okay, I did not actually sugarcoating anything. Okay, and then I hope you, if you follow the way I tell you to do, you should have no problem actually getting a good score for the midterm. Okay, so recently I got a lot of emails from students, and then those students, they say they spend a lot of time working on the midterm one, but score poorly for the midterm one, right? And they ask me how to improve. Then I ask them, do you watch all my videos? Okay, and then 90% of the time, They keep saying that they actually go through all this workshop. No, they have these tutorial things, right? They spend a lot of time over there. They read the textbook. They did all they can, except watching my video. So that put me in a very difficult situation because I'm a professor who's trying to help. I will be responsible to whatever I say to you. Okay, those are the things that I can control, right? I tell you this will work. If you follow it and it doesn't work, come back to me. Okay, I need to figure out a new way for you. Okay, because what I say to you doesn't really work for you, then I need to figure out something for you because I'm your instructor. That's the things I'm willing to do. Okay, even though they will take me a lot of time, that's my responsibility. Okay, however, if you do your own way, okay, and then did not take my advice, it is very difficult for me to tell you what to do because I have a feeling that even I tell you what to do, you are not going to listen to me. So that kind of put me in a very difficult situations, right? So I want to help, but you are not actually trying to be coached by me, then I don't know how to do more for you. All right, so if you are not satisfied with your midterm 1 grade, then we need to connect, okay? But be honest, I feel like only those students that are willing to be coached, okay, then my method will work. Okay, if you are not willing to actually follow the lead, then it just says, okay, the way I try to provide doesn't work for you. Okay, then maybe consider actually dropping this class, right? Otherwise, it's just wasting, each other's time. There's no point. Okay. Yeah. So, but like I say, the things that matter the most right now is really to go back and check your midterm 1 seriously. Okay. If you do well, great. Okay, I'm very happy for you. Okay, there's already several students come to my office and tell me, okay, how great they did for the midterm. And then they say, like, they just follow what I say. And they did poorly for their midterm 1 and they do great now. They feel like it's amazing. Okay, so for those kids, I'm very happy that I can help. Okay, and I hope most people have that feeling. Okay, so if you did not actually get a benefit, okay, consider really connect with me, talk to me, follow my lead. I think that will be an easy way to get the grade that you want. Okay. And I also want to emphasize, not everybody need to get an A for this course. Okay. All I want to have is that you get the grade that you want. Okay, like I say, chemistry is not the most important thing in the world. Depending on your major, okay, this could be just a lecture or a course that you need to take. Okay, so you need to know what is your goal. Okay, I wouldn't because you get a C, then I say, okay, you're not a good student. No, I wouldn't say that. Okay, all I care about is actually do you achieve your goal. Okay, so that's the most important thing. Okay, so with all that being said, okay, there's actually one more thing you need to do to boost your grade. Okay, so on Team side, I just post that there's actually a midterm survey. Then you can actually get 1 extra point. Okay, you can do this survey. You can do it as long as you want, okay, but finish it by the end of next Wednesday. Okay. So I do hope that you guys can actually provide me some insight about the things that you want me to do more, so I can actually better help you to get the grade that you want. Okay, so I know some of them will just click, 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 okay, and then submit. It's not very helpful to me. Okay, let's actually, I think only 3 or 4 questions that you need to actually write down your opinion. Okay, so please actually write down your opinions that I can actually make this lecture more effective. All right. Okay, so I think that's actually all the things I want to say so far. Okay, any other questions? Okay, so let's check. Are there any other questions here? Okay, we're trying to actually go through the things that we went through last time. Okay, I'll give you a few more examples to reinforce those concepts. That is fine. I think you only have 1 week to review your midterm 1. Okay, so when you have the access to it, make sure actually you have all those questions print out. Okay, or find a way to actually screenshot all those things. Okay, do whatever you want. Okay, but make sure you have those questions. It's very important because when you hit the finals, you want to actually go back to those midterm questions. Make sure you know all the things that in those questions. Okay. Or another thing that's very important. I feel like I did not emphasize this enough. Okay. So all the questions actually from a single data bank. Make sure you have enough classmates, enough good friends that you can actually exchange the questions. Okay. By exchange those questions, you will be able to actually pull all different kind of questions that's going to show up in your finals. Okay, so we need to actually contribute this and make it a collective effort. Okay, so that our section can actually do much better than other sections. All right. What was the average score on the midterm? We will have a serious review. Okay, I'll give you a serious report on how we perform for our midterm 1. Okay, right now I'm actually waiting for the data from the managers. He's actually the only one who have the information of all sections. I only have the information for our sections. All right. Good. Stay positive. It's important. Okay. Yeah, you have 1 week to actually check your midterm 1. Okay. And then all you can do is actually show me how you get your answer. And then I will make the decision whether you got a partial credit or not. What time is my office hour tomorrow? 9 to 11. Okay, but sometimes I feel like 9 to 11 things not so convenient for our class. Okay, so I'm thinking about modify the office hour a little bit to fit everybody's schedule a little bit better. Okay, and then so far the best schedule I found for everybody since it's actually like Thursday 11 to 12. Things actually a good slot for everybody. Okay, so I will probe a little bit more. Then I will actually update the office hour. Okay. You missed the conceptual question, but got all the calculation right. You are very unique. Okay, so conceptual questions, then I think we actually reviewed many conceptual questions. Okay, and then I do believe that we cover all the concept that you need to know. Okay, so if you feel like you're missing the conceptual questions, I want to actually revisit the video. Okay, or you want to connect with me. Okay, show me where you did wrong. Then maybe I can just tell you what are the right concept to have. What do you check the test if it has any problem? Okay, so what other things, what other conditions you are going to get partial credit? Okay, so if you can show me how you get your numbers step by step, okay, and then you are indeed using the way I asked you to do so. Okay, you maybe make some miscalculation at the very last step. Okay, then I will give you partial credit. Okay, in fact, that's already a student. No, I think he did that already. Okay, so he showed me his work to calculate the equilibrium constant. Okay, and then clearly at the very last step, he did it wrong. Okay, but he has no problem actually explain how he actually did all the things to me. And he got a partial credit back. Okay, so those are the things that you should actually focus on for this week. Okay, so I will work. So if you have any questions that you don't know how to solve, but you want me to actually solve it, post it to the channel, okay? I will collect those problems and then we'll review those things in the next lecture. On the actual credit survey, it's 1 yes and 7 no. No. 7 is actually the highest score. Okay, not the other way around. Okay, so I want to actually have all the number go all the way to 7. Okay. Okay, so I answer this one. Okay, congratulations. But I feel like you are trying to. Okay, nothing. I actually don't know the average of the whole section yet. Okay, but we have actually a very interesting distribution. We have a peak around 60. We have another peak around 80. So we start to have bimodal distribution. That means actually the student who actually really follow the lead, I guess, is the one who is actually in the peak at 80. Okay, but let's actually another pool that doesn't really use the resource wisely yet. Okay. But we'll have those discussion in the next lecture. I'm a little bit confused about this question. I thought I upload all the videos on Teams, right? Yeah, so except the one I asked you to watch before the lecture, those are on the YouTube. Okay. All the other in-person lectures was actually summarized on Teams. Okay, let me show you so that you know where to find it. Okay, so you can see for the midterm one, these are all the recordings that we have for every week. Okay, so it's actually summarized here. Okay, so we will start to have all the things. I forgot to post it last time. Huh? If you find that I forgot to post the video link, okay, message me, please. Okay, and the other way to find the recording is actually all here. Okay, so you can actually find all this recording in every week's channel as well. Okay, the reason I post on the general channel is because that's easier to find, right? You don't have to actually go to individual channel to find all things, but it is actually over there. Okay, so let me see. I think I finished almost all the questions, right? This is done, this is done. Can we get partial credit on multiple choice question? Depends. Okay, so when we see you need to actually show me, okay? And it's actually my job, okay? I need to actually gauge, okay, how much you actually understand the concept, okay? Then we'll start from there. Okay, so I think that's actually all the questions that we have for this week. Okay, so then let's get back to chapter 13. All right. Oh, one more thing I want to talk about the midterm 2 is that midterm 2, based on the statistics, actually the midterms that students score the poorest. Okay, so typically we see a drop of average by probably 7 point. Okay, meaning that if our midterm 1 average is 65, then your midterm 2 will go down to like 58. Okay, so that is actually the typical range we have observing so far. Okay, and the main reason for that is because the calculation. Okay, so for midterm 2, the things we are going to do all the time is to calculate the pH of a water solution. Okay, that's all you do. Calculation of water solution, the pH of water solution. Okay, and then in all the other sections, we are going to go through this ice table all the time. Okay, and from my personal opinion, I think there is actually a reason that one student actually score poorly. Okay, because using ice table takes too much time. Okay, and we're going to show you why very soon. Okay, and then for our section, I will strongly encourage that just use the equation. Okay, after we went through the ice table first, and then to tell you, okay, why we can actually get that specific equation. Okay, so that is actually the main thing. Okay, to calculate the pH of solution. Okay, the other very important thing that you want to be very good at is like you want to know what kind of solution that you have. Okay, so in the previous lecture we talked about acid, we talked about base, right? We talked about salt. Okay, there's actually another very important one is called the buffer. Okay, so buffer is actually the one that I guess most students will get very confused. Okay, and then the most confusing part for midterm 2 is actually something called the acid base titration. Okay, because that's actually going to evolve all different kind of solutions when you add in different amount of titrant. Okay, so those are the things that you want to be very good at. Once you see a solution, okay, for midterm 2, every time you see a solution, the first step is always to identify what kind of solution that you have. Okay, so remember this. This is true, especially true for midterm 2. Okay, if you can really identify the solution without any problem, then most likely you will feel actually midterm 2 is actually very easy. Okay, so any other questions? If not, let's review a few simple concepts that we went through last time. Okay. So last time, the first concept we introduced is the conjugated acid base, right? Okay, so assuming today you have a species A, you want to find out the conjugate base of A, the conjugate acid of A, then what you do is actually you add in a H plus, a proton, right? So once you add it up, you know you're going to have a HA plus. Okay, so in this case, we call the HA is the conjugated acid of A, right? Similarly, you can actually also say the A is the conjugated base of HA plus. Okay, so the main difference between the two is actually the H plus, right? The proton. Okay, so if you want to find out the conjugated acid of one species, what you really do is actually just add H plus to that species. Okay. To find out the conjugated base of something, what you do is actually you minus H plus, right? So you minus H plus, then you can get the conjugated base of this specific species. The things that got you confused is that what if today I want to find out the conjugated base of A? Well, A doesn't have H plus, right? So what is the conjugated base of A? You don't have H plus, right? So what do? Instead of minus H plus, you add in OH minus. Okay. So this is actually equivalent because you are in the aqueous solution. Okay, since you can actually minus H plus, all you do is actually add in OH minus. Okay, so this actually is something that you want to know. Okay. All right, so this is actually the first concept we went through last time. Any questions? Okay, so if not, let's do some practice. Let's start from this species. Okay. If you want to know the conjugated acid of this species, what do you get? Yeah, it's H3PO4, right? Because what you do is actually you add in H plus. Oh, one minus. Sorry, this should be actually 1 minus. My bad. Okay. So if you add in H plus, then the proton number increases by 1, right? The negative charge now become neutralized. Okay, so that's actually the first thing you do, right? Okay, so what if I want to find out the conjugated base of this species? Then what you do is actually you subtract H plus, right? So that you have HPO4 2 minus. Okay, so it's always less shift of the proton. Okay, so that's actually the first important concept we need to learn. All right. Everybody's fine with all this? Good. Okay. And then the other very important thing we talked about in the previous lecture is that we need to know the strength of acid and base, right? Which one is actually stronger, which one is weak. Okay. So we talk about the 4 principles. These are the 4 principles, right? So most of the substance you see is actually weak acid or weak base. That's actually the rule number 1, right? Rule number 2, we only have 7 strong acid. Okay, where the strongest one is actually HI, HBr, HClO4, HCl, HClO3, H2SO4, HNO3. Okay, so those 7. You need to actually memorize the order. Okay. For the strong base, we say we need to know this 1A and 2A oxide or hydroxide. So those are the strong base. Okay. So let's actually the rule number 2 we need to know. Okay. The third one is that if you use the periodic table, you know if you move to the left, go to the bottom, that's where you're going to find the stronger base, right? If you move to the right, to the bottom, that's where you're going to find the strong acid. So those are the principles that you really need to know. Okay. The very last one is actually the oxalic acid, right? It has always have this chemical formula. Let's start from H, X, center atom Y, and then oxygen to higher value, right? So if you have the same center atom, okay, then the one has larger difference between the oxygen and proton. Okay, that one will be actually a stronger oxalic acid. So those are the concepts that we went through last time for the second point. Okay. And the very last point we went through last time is if today I give you a salt, okay, once it dissociates into water solution, can you predict the solution is acidic, neutral, or basic? Right? And the concept that we learned from there is that if you have a cation, okay, then it can only be either neutral or acidic. If you have an anion, it can only be either neutral or basic. Okay. The conditions that will make this ionic species neutral is that they must belong to the conjugated acid or base of strong acid or base, right? Otherwise, just cation become acidic, anion become basic. Okay, so those are the summary about the things that we have learned in the previous lecture. Okay, so what we're going to learn today is actually the core of chapter 13. Okay, we're going to tell you the equation that you need to memorize, which is, I'm going to highlight the things that you need to know. No, we don't talk about this yet. Okay, so we're just talking about a simple case. Okay, so first we're going to focus on the things we highlight. Okay, for today's lecture. Okay. So the first concept that we need to actually understand is actually we need to know the definition of pH. Okay. So the pH, okay, the P stands for negative log. Okay. So let's actually what P means. Okay, always negative log. Later on you will learn pKa, pKb is the same P. Okay, what it means is actually negative log. Okay. H is actually a representation of your proton concentration. Okay, so if you know the proton concentration of your solution, you take the negative log of that, then you get the pH of that solution. Okay, so that is actually the first fundamental concept that you need to know. Okay, any question for this? No? Okay. Let's talk about the strong acid solution. Okay. First, what does strong acid means? Very good. That's actually key. 100% dissociation. Okay, so let's say you have one M HI aqueous solution. Can you calculate the pH? Okay, so this is actually a very standard questions you can see. Okay, so how do you actually handle this? First, you need to know HI is a strong acid, right? And then you should know when we say it's strong acid, it means they're going to dissociate 100%. Okay, so since it's an acid, then you know it's going to generate photons, right? And then, therefore, you know that's actually the equation that you need to use, right? Okay, so you know, let's go do this very standard way that people will tell you how to do it. Okay, so in the beginning, you know, you have 1 M of HI, right? And it starts to dissociate. And since it's such a strong acid, it's going to dissociate 100%, right? So in the change part, what do you write? You write -1, right? And then here you will put 1, here you will put 1. Okay, then your system will reach equilibrium. Once it reaches equilibrium, you don't have actual HI anymore in your solution. Okay, all you have is 1N H plus and then 1M I minus. Okay, everybody follow this so far? So from this simple analysis, then you know the proton concentration at equilibrium is actually going to equals to your original strong acid concentration and equals to 1m, right? So how do you calculate the pH of this solution? Since the pH is defined as negative log, so it's log with a base of 10, okay? What do we got here? Anyone have calculators? Or anyone is actually, very good at math? You should actually see the answer very quickly, right? 0, right? Okay. That will be actually the answer. Okay, but okay, 1 is 10 to the 0th power, right? Yes, this means initial, right? Okay, so this is actually a very simple calculation. And then you can, of course, go through all this ice table, right? But it will always give you the same thing. So the things I want you to actually memorize is not this. Instead, these are actually the things I want you to memorize. For strong acid, the proton concentration will actually equal to your initial strong acid concentration, right? Therefore, if we go back to our table, see what I put here? The proton concentration, okay, I write H3O plus, right? So this is actually the same as your H plus. It's going to equals to the initial concentration of your strong acid, right? Therefore, the pH is simply calculated by this, right? Negative log of your initial strong acid concentration. You can just do less simple calculation to get the pH. Okay, so this is actually things that I want you to memorize. Okay, and then when we see this question, what should we do? The first step is what? Identify what kind of solution that you have, right? So you see the things is what? Strong acid. HI is one of the strong acid, right? Then you know to calculate pH, all I need to do is just take the negative log of whatever concentration is specified for that strong acid. Okay, you don't want to go through the ice table. You don't have that time. Okay, so the key is actually, can you recognize the solution that you have? It's strong acid. If it is strong acid, pH is going to equal to negative log of your initial strong acid concentration. Okay, so those are the things that you need to do. Those are the things that you need to get used to. Okay, for example, what is the pH of 0.01 m H0O4 aqueous solution? Okay. -2. Just think about it. Okay. So first is actually, okay, let's do it slowly, just in case. First, you need to know what is the H0O4 aqueous solution, right? This is actually the strong acid, right? So you know you have a strong acid, right? Then since it's actually a strong acid, then you know your proton concentration is going to equals to the strong acid concentration, which is going to equals to 0.01 m, because it dissociates 100%. All right. So the pH, which is going to equal to negative log of your proton concentration. Therefore, it's actually equal negative log of 0.01. And then this is negative log 10 to the negative 2, right? Therefore, you got a pH value of 2. Okay, so key here is really to identify what kind of solution that you have, so that you will know what equation to use, right? Okay, so that's actually the case for the strong acid. All right, any questions? Okay, we're going to do a lot more practice later on today, okay? Now let's look at some interesting and then probably actually most commonly seen situation. Why today you have a weak acid? How to calculate the pH of a weak acid? Okay. So let's do a example. Okay, this one is okay. So this question says calculate pH of 0.1 m solution of ascorbic acid for which the Ka value is 1.0 times 10 to the negative 5. Okay, so the first step is actually to identify what kind of solution that you have, right? Whether it's actually strong acid, weak acid, strong base, or weak base. So what kind of solution do we have? Hmm? What kind of solution do we have? Acid or base first? Good. Okay, strong or weak? How do you know? It's not one of the 7, right? Weak. That's actually another very important hint here. Ka, okay? You will not see a Ka value for strong acid. Okay? And I will tell you why. They say you have an acid. It's going to dissociate, become H+, and then it's conjugated base. Okay, so this is actually a very general chemical equation that you can have, right? How do you write the Ka? The K is the equilibrium constant, which is actually the things you learn from chapter 12. Okay. So therefore, you know the Ka should be expressed as proton concentration times your conjugate base concentration over acid concentration at equilibrium, right? The reason it's labeled with a subscript A is telling you this is actually a equilibrium constant for acid. Okay, so later on we'll see Kb, meaning it's actually equilibrium constant for a base. Okay. So now you see this equation, Ka equation. What is the denominator? The concentration of your acid, right? So this is actually the concentration at equilibrium, not initial, right? But at equilibrium. All right. Now think about this. You have a strong acid. It's going to dissociate 100%, right? What would be the concentration of less strong acid at equilibrium? 0, right? How will make your Ka be? Infinity, right? So for the strong acid, we don't write Ka because it makes no sense. Your denominator is actually 0. Okay. So with that being said, if in a question you see a Ka, he actually tells you the acid that you have is a weak acid. Okay. So those are the things that you can figure out what kind of solution that you have, right? If you're actually good, you know what the 7 strong acid is. You don't even need to know the Ka, right? You know it is actually a weak acid solution. Okay. But if you don't have that concept, by looking at the Ka values, you know it's actually a weak acid. Okay. And I want to pay attention to those Ka value. Most of the time, you're going to see that value is smaller than 10 to the negative 4. Okay. Meaning you can use small x approximation. Okay, we mentioned the things in chapter 12, but we didn't use it. Okay, we'll start to use that in chapter 13. All right. Okay, so now we go back to our very old methodology, ice table. Okay. You know you have a weak acid, ascorbic acid. I don't really care about its chemical formula. Okay. I can just write HA to represent the weak acid. And I know the initial concentration is 0.01. Okay. Here, you should see that I assume that ascorbic acid as a acid that only dissociate to generate a single proton. Right? I did not say it generates 2 protons or 3 protons. How do I know that? How do I write just H plus, not 2H plus or 3H plus or 4H plus? The reason I can write this is because if you look at Ka, it's only one value, right? Okay. So this is so-called a monoprotic acid, meaning it only generates 1 proton at a time. Okay. If you're a biprotic acid, you are going to have Ka1, Ka2, so on and so forth. Okay. So since here you only write Ka, right? That means it's actually a monoprotic acid. That's why you can simply just use HA to represent its identity. All right. So once you write down its initial concentration, you know it is not strong acid. Therefore, it's not going to dissociate 100%, right? Therefore, you say, assuming it dissociate by X, yes. Do I put 0.1 or 0.01? Oh, 0.1, sorry. Thank you. Okay. So since it did not dissociate 100%, I say it dissociate by X, right? And then by now, you should know you have plus X here, plus X here. Therefore, once you reach equilibrium, you have 0.1 minus X, X, X. Okay. So once you know all these things, then you can put into your equilibrium constant K. Therefore, you're going to get X times X for your numerator, 0.1 minus X for your denominator. Okay. So this gives you X squared over 0.1 minus X. And then this whole thing will equals to 1 times 10 to the negative 5. So you're going to get to this point. All right. Up to this point, the next thing we want to actually recall our memory is that in chapter 12, we say if your X, if your equilibrium constant K is lower than 10 to the negative 4, then you can actually apply small x approximation. What it means is that these things will be actually very small. Okay, small x. Therefore, these things can be approximated into this. Okay, and this is going to be equal to your Ka, which is 1 times 10 to the negative 5. Therefore, you know the x squared is going to equal to 0.1 times 1 times 10 to the negative 5. Here, I want to emphasize this 0.1 is actually the initial concentration of your weak acid, right? 1 times 10 to the negative 5 is actually your equilibrium constant of the acid, Ka. Okay. Therefore, you know your x is actually going to equals to HA initial times Ka. You take the square root of that, you can get your x, right? And then we know x is actually representing your proton concentration. Therefore, we can just generate this as the proton concentration of a weak acid can be calculated using this simple equation. This is actually equation that you actually memorize. Okay. And then to get the pH, again, you go back to this simple equation again. That's how you calculate the pH of a weak acid. Okay. So, everybody follow? Everybody follow this? Okay. Okay, so with that being said, come back to these questions. If you know all the things, this is actually how you're going to solve these questions. Determine the pH of 0.1 N solution of ascorbic acid for which the K is 1 times 10 to the negative 5. Okay, first step, identify what kind of solution that you have. You should know it's actually weak acid, right? Second, how to calculate the proton concentration of weak acid? Square root of original weak acid concentration times your Ka, which is going to give you 0.1 times 1 times 10 to the negative 5, which is square root of 10 to the negative 6, which equals to 10 to the negative third, right? That's actually your proton concentration. Okay, then after that, step number 3, pH equals to negative log of your proton concentration. It's going to equals to negative log 10 to the negative 3. Give you that final answer of 3. Okay. So the beauty of doing all this is that you don't need to draw the ice table anymore. Ice table is going to slow you down so much. You don't have time. Okay, so the things that you need to practice a lot for this chapter is really identify what kind of solution that you have. Okay, so recap. So far, we talked about 2 things. One is actually a strong acid. One is actually weak acid. For the strong acid, it's going to 100% dissociation, right? So the proton concentration will equals to your strong acid concentration that was provided in the question, right? All you do is actually says the proton concentration equals to strong acid concentration. So the pH is negative log of strong acid concentration. Okay, and that is actually the things that we provide right here. Okay. The second solution we talked about so far is actually the weak acid, right? By going through all these ice table and the small x approximation, then you know the proton concentration can be calculated through this. the square root of your weak acid concentration multiplied its equilibrium constant. Okay, it is always true. Okay, so all you need to do is actually memorize the equation and then practice that. Make sure you actually, when you operate your calculators, make sure you actually do it right every time. Okay. Once you know how to calculate your proton concentration, the next thing you do is just take negative log of that, then you get the pH. Okay. With that being said, I want to actually start to associate this. Then suddenly you actually memorize many equations very easily. Okay. Strong base. Okay, so strong base is actually very similar to your strong acid condition. Okay, but instead of to provide the proton concentration, what it is going to provide is actually your hydroxide concentration. Okay, so what we do is actually going to replace the proton with hydroxide. Okay, if you have a strong base, then your hydroxide concentration, okay, so go from proton to hydroxide, is going to equals to your initial base concentration. Okay. And then once you know the base concentration, you can calculate so-called the pOH. Okay. So what is the definition of your pOH? P is negative log of 10, right? So negative log of your hydroxide concentration. Okay, so this is actually something that you also need to know. pOH is actually negative log the base of 10 for the OH minus concentration. Okay. And then you can calculate your pH from pOH by knowing that for aqueous solution, the pH and the pOH, if you're adding up, it gives you a constant 14. Okay. So that 14 actually comes from water. Okay, so this is actually something that you need to actually memorize. Okay. Since right now you know how to calculate your pOH, okay, then you should be able to use this equation to back calculate what the pH is for that specific solution. All right. The very last thing I want to talk about today is this. If today you have a weak base, okay, then what we do is actually we replace the H plus with OH minus. Okay. We replace the initial weak acid concentration with weak base concentration. We replace the Ka, make it become Kb. Take square root of that. Then you can get the OH minus concentration of a weak base. Okay. And you take negative log of OH minus, you get pOH. 14 minus pOH, that give you your pH. Okay. So suddenly we actually can memorize all these four equations. Okay, and this can solve about 80% of the question you're going to encounter for this chapter, for the calculation part. Maybe 90% actually. All right. So these are the four equations that I want you to actually memorize. Okay. The very last one I want to talk about today, before we actually do a few practice, is that you're going to be asked to calculate so-called the percent dissociation for your weak acid or weak base. Okay, and the way you calculate it is very simple. What you calculate is actually, you want to figure out your proton concentration over your initial acid concentration, then multiply 100. Okay, or your OH minus concentration over your base concentration in the beginning times 100%. That's how you compute the percent dissociation. All right. So that's pretty much all the calculation that you will need to know for this chapter. Okay. Any questions? On the table, we say the. Okay, so this is actually a good question, and you want to actually think through this. Why do I put plus here? Yeah, because it's actually a negative log to give you the pH, right? So what this actually means is actually 14 minus negative log of your BOH, where this guy is actually your POH. Okay, so it's actually 14 minus your POH that give you pH. Any other questions? Okay, so that's all the 4 equations we actually learned today. Okay, we're going to do some practice now. Calculate pH of 0.6 m solution of acylamine. What is the first step? What is the solution that we have? Weak base, right? How do we know it's actually a weak base? Everybody now can see the keywords. KB, right? So apparently it's actually a weak base. Okay, so weak base, right? So that we know we can calculate the OH minus concentration equals to your base concentration multiply your KB, right? So let's actually think that you need to memorize. Okay. So what is the concentration? 0.6, right? Okay. And then what is the KB? 5.6 times 10 to the negative 4. Okay. So if you do like calculation, type of that value. Anyone have calculator can borrow me so we can just calculate the number of this. Really? I feel it's not. 5 point something, right? 5.79. See how crazy you guys can be when play on the calculator. Then, okay, let me see. So this is actually 3.36 times 10 to the negative 4, right? Okay, so 3 points, so take the square root of that. From 1 point something. 1.8 something times 10 to the negative 2. Something like this, right? Okay. Come on, this is actually the part that only you can do it for yourself. Okay, I cannot do it for you. Okay, so you know that's actually your OH minus concentration. All right, practice this, make sure you know how to actually push the button on your calculator. So POH is going to equal to negative log of 1.8 times 10 to the negative 2. Should be 1.8 something. Okay, so what's the value of this? If you take the negative log of that, 1 point something, 1.74. That's actually your POH, right? Therefore, you know the pH is going to equal to 14 minus your POH, which equals to 14 minus 1.74, which is going to give you 12.26. Okay. So, recap. Step number 1, know what solution that you have. Okay. Step number 2, calculate your hydroxide concentration, right? And then convert that into your pOH. Very last step, calculate your pH from pOH using 14 minus pOH. That's how you get the answer of this question. All right. Okay. So one more. This is actually the trickier one, and will be the very last one we discussed today. Okay, what is the pH of 0.269 m methyl ammonium chloride? The Kb of ethylamine is a certain value. Okay. First things, what kind of solution do you have? So this one is actually the one that you want to pay close attention to the nomenclature, and then the Kb. Okay, what is the Kb described? Is this guy, ethylamine. Okay, what you have is what? Methyl ammonium chloride. Are they the same? They are not the same. Okay, so how do you actually solve this? If you see these two are not the same, also look at what is the things that you have in the question, right? So ammonium chloride, C2H5, NH3Cl. What is this? Who says strong acid? Okay, so remember, okay, so in the previous lectures, okay, we talk about acid, we talk about base. There's actually one more thing we talk about. The salt. This is a salt, right? If you cannot see it's a salt, let us actually put it into. Okay, so either you have acid, base, or salt. For now, later on we have buffer. Okay, but right now what we have is actually acid, base, and salt. We went to actually how to calculate the pH of acid, pH of base. Now we actually enter in the pH of salt. Okay. With that being said, can you see once these things dissociate, what do you have? What do you have? Let's start from the simple one, right? We say if you see this, it's going to be Cl minus, right? And all the others should actually go together. So you're going to have C2H5 NH3 plus. Okay? So let's actually think that you need to be very good at. Okay, now tell me, what is this guy? What is this guy? Is this the same as this? They are not the same, right? How are they different? One extra proton, right? So this and that, the main differences is that the species that we are interested in has one extra proton than this guy, where we know the Kb, right? Okay. So now tell me, what is the solution that we have? We will say the cation can only be acid or neutral, right? And then the way you judge is acid or neutral is based on its conjugated partner. Okay, if it's actually a strong acid, strong base, then this guy will be neutral, right? But apparently, its conjugated base is this guy, right? So its conjugate base is actually a weak base. Therefore, this guy will be a weak acid. Okay, strong acid you only have 7. Okay, so for the conjugated the conjugated acid of a weak base will be a weak acid. Okay, a conjugated base of, am I saying the same thing? So the conjugated base of a weak acid will be a weak base. Conjugated acid of a weak base will be actually a weak acid. Okay. Strong acid will have 7 of it. Okay, nothing more. Okay. Okay, now I'll come back to this. So we know this one is what? Weak acid. Okay. Do you know how to calculate the proton concentration of a weak acid? You do, right? Square root of the concentration of whatever you have in the beginning multiplies Ka. Do you have Ka here? You don't have Ka, right? So here is actually the part that you want to know. It's actually a very important concept for the aqueous solution. The Ka and Kb of a conjugated acid base, when they multiply, they give you a constant 10 to the negative 14. Okay. So now, do you know the Kb? You do know this, right? Can you compute your Ka? Now you know your Ka, right? So now this become a known things, right? And then you know the concentration of this, right? Because the salt that we have is a soluble salt, it's going to dissociate 100%. Okay, so whatever concentration that you have for this guy will be the same concentration for your acid. Okay, so now you know the acid concentration. Now you know your Ka. Things become very simple, right? Because the proton concentration of a weak acid is just simply square root of your acid concentration is 0.269. Ka is 10 to the negative 14 divided by 4.3 times 10 to the negative 4. Okay. This is actually how you calculate your proton concentration. Okay. If you can see this, it's actually a very easy calculation, right? So once you know the proton concentration, the pH will simply equal to negative log of this proton concentration. Okay. So if you have your calculators, calculate this, okay? But I believe the final answer will be 5.6. All right. So to summarize the things that we want to emphasize today is that for chapters 13, 14, and 15, every time you read a question, the first thing you want to ask yourself is what? What kind of solution do I have? Okay. Strong acid, strong base, weak base. It's actually a strong acid. Proton concentration is going to equal to your acid concentration. Technical log, you give a pH. If the actually is weak, then the square root of acid concentration times your Ka. Okay, technical log, you got your pH. Okay, so it's as simple as this. Okay, so you know all this calculation. Go back home and practice your homework. All right, so that's it for today. Thank you.